So we are continuing here with the fundamental theorem of calculus part 2. I need to take the antiderivative. Antiderivative of 1 is just x because I have a dx there. And then the square root of x, I'm going to write that as x to the 1/2. Add 1, which gives me x to the, I'm waiting for somebody to say x to the 3/2. Thank you. And then I'm going to divide, which gives me 2/3. And so fundamental theorem, part 2, it's evaluated from 4 to 9, and I'm going to plug in my bounds and subtract. So I'll plug in the 9. So that gives me 9 minus 2/3, 9 to the 3/2. And then I'm going to subtract and plug in the 4, and that gives me 4 minus 2/3, 4 to the 3/2. And so this problem is similar to one we did yesterday. Again, we are in the calculus jungle. And so how do we do 9 raised to the 3/2? 9 to the 1/2, which is the square root of 9. And then cube it. So 3 cubed is 27. And then 27 times negative 2/3. 3 goes into 27 9 times, and 9 times 2 is 18. So this simplifies to 9 minus 18.
Can you like go over that?
Okay. Okay. So I want to write this as 9 to the 1/2 raised to the 3rd power. 9 to the 1/2 is the square root of 9, which is 3. Correct?
Yeah.
So I have 3 raised to the 3rd power, which is 27. 3 times 3 times 3. So then I have 27 times negative 2/3. You with me?
Yeah.
So that simplifies to 9. So I have negative 2 times 9, which is negative 18.
Oh, okay.
Okay, and similarly, I'm going to do the same thing here. So I take the square root of 4, which is 2, and then cube it, which is 8. And then I have 8 times negative 2/3, which is negative 16 over 3. And now I'm going to simplify. So this gives me negative 9 minus 4, which is negative 13. This gives me positive 16 over 3. So I'm going to get a common denominator. So let's see, that's negative 39 over 3 plus 16 over 3, which gives me a final answer of negative 23 over 3. All good? Any questions on that one? All right. Well, we need to look at one more thing. But before we do, I need to clarify something. So we have what we refer to as net area. And net area is the value of the integral when we're talking about the area under the curve. And that can be either positive or it can be negative. So this is like what we did on your review, for example, on Tuesday, where you have the integral from -4 to 2, for example, and you have to find that value. It could be either positive if it's above the x-axis or negative if it's below the x-axis. okay? And then we have what is called total area. And total area is always positive. And so sometimes we must take the absolute value. It does not make sense, for example, if we are talking about the area in this classroom, it doesn't make sense to talk about a negative area, right? It's a measurement. Total area is always positive. Many times we're talking about a measurement. All right. So, for example, like in terms of physics, velocity is like net area. It can be positive or it can be negative, whereas total area would be like speed, because speed is the absolute value of the velocity. Okay, but if we are measuring square footage, for example, that is total area and that has to be positive. If we are talking about a business, gains and losses, did they make money or did they lose money? Well, that can be positive or that could be negative. That's like net area. Okay, so here it says calculate the area of the region between f of x is equal to 0, excuse me, and g of x is equal to x squared minus 4x. This is total area. All right, because I'm finding how much area here is bounded by these parameters. So I am going to integrate from 0 to 4. My function is x squared minus 4x. And since all of this area is below the x-axis, I'm going to get a negative value for this integral, but I must make it positive since I am finding total area. So I'm going to take the absolute value of the final answer. That makes sense? All right, so what's the antiderivative of x squared? 1/3 x cubed. Minus, what's the antiderivative of 4x? 2x squared. And then I am evaluating it from 0 to 4. So I'm going to plug in the 4. Excuse me, that should be x. Let me rewrite that. That should be 1/3 x cubed. So I'm going to plug in the 4. 4 cubed is 64. So I have 64 over 3 minus, I plug in the 4 here, I get 16 times 2, which is 32. And then when I plug in 0 to both of those, I'm going to get 0. So I have 64 over 3 minus, I'm going to get a common denominator. Common denominator here is 3. So I'll write this as 96 over 3. So 64 minus 3, 64 over 3 minus 96 over 3 gives me negative 32 over 3. However, I must take the absolute value since we are talking about total area. Therefore, my final answer is positive 32 over 3.
So in this manner, would we like do like units next to it, or like is there no measurement?
If the units are provided, yes. But in this case, no.
Yeah, how should you tell again if it's total area or net area?
Okay. So if it says calculate the area of the region between these two things, that is always total area. Okay. If we are doing a problem like you did on the review on Tuesday, where it just has what's the value of the integral, like if this had said what's the value of the integral from 0 to 4, then it would be negative. Okay, but if it's asking you to calculate the area of the region, that is total area. So that is the first example. The second one here, notice on the first one we had all of the area below the x-axis, so we took the absolute value of the final answer. But here they are split up. I have some above the x-axis and some below the x-axis. So what do you think we will do? How do we solve this?
Add them.
I am going to add them together. add what together?
The area.
So what you're saying is I need to split this up. So I have the integral from 0 to 1. That's the area that's above the x-axis. My function is 1 minus x squared dx. And I'm going to add that to the second part, which is the integral from 1 to 3 of 1 minus x squared. So I'm going to find the value of this integral and then add that to the value of this integral, but I need to take the absolute value of the second part here because all of that area is below the x-axis. Make sense? All right, so antiderivative of 1 is x, and the antiderivative of x squared is 1/3 x cubed, evaluated from 0 to 1. So I plug in 1, which gives me 1 minus 1/3, and then the second part is 0. So the value of the area in this top region here is 2/3. And then my antiderivative here is going to be the same, but it's evaluated from 1 to 3. So I'm going to plug in 3, which gives me 3. And here, let's see, that's 27 divided by 3 is 9 minus 1 minus 1/3. So this will give me -6 minus 2/3. So I have -6 and 2/3, and I take the absolute value of that. So my final answer here, I'm going to add these two things together. I have 2/3 plus the absolute value of 6 and 2/3. So 2/3 plus 6 and 2/3, that gives me 7 and 1/3, or 22/3 for my final answer. So if all of it's below the x-axis, we're going to integrate and then take the absolute value. If it's split, I'm going to split it up by the bounds. And if it's below the x-axis, take the absolute value and then add that to the positive one. And then the last example here, this one is entirely above the x-axis, so I don't need to worry about the absolute value, but there are two different functions here. So it says calculate the area shown bounded by the x-axis and the functions y is equal to x cubed and y is equal to square root of x. So this is the square root of x. This is x cubed. So this time I have the integral, the square root of x, the bounds are from 0 to 1. And I'm going to write that as x to the 1/2. And the second one, my bounds are going from 1 to 2. And I have x cubed. And I needed the x there. So the antiderivative of x to the 1/2, I add 1 to the exponent, which gives me x to the 3/2, and then I divide, evaluated from 0 to 1. So I plug in 1, and I get 2/3. And this one, my antiderivative is 1/4 x to the 4th, evaluated from 1 to 2. So I'm going to plug in 2. 2 to the 4th is 16 divided by 4 is 4. And then I plug in 1, which gives me 1/4. So I have 4 minus 1/4. So I have 2/3 for the first part and then 3 3/4 for the second part. And I need to add those. So I'm going to get a common denominator. See, this would be 2/3 plus 15/4. So my common denominator is 12. So I get 8/12 plus 45/12, which gives me final answer of 53/12.